Consider the number 10. It's the product of two numbers, 5 and 2, which are neither 1 nor itself. So 10 is not prime. On the other hand, 11 is divisible only by 1 and itself, so it is prime. The first few primes are 2, 3, 5, 7, and 11. The question then arises, do they go on forever, or do the primes eventually stop? To find out, let's assume you have a finite list of all the primes. Multiply them together, and you get a product. And each prime divides into that product with remainder 0. Therefore, it's certainly not prime. But what if you add 1 to it? Then every prime you have divides into the new number and leaves a remainder of 1. So, since it's not the product of primes, this new number has to be a new prime. But your assumption was you knew all the primes and it was a finite list. Therefore, your assumption is contradicted, and the primes actually go on forever. Let's look at this in reverse to provide a different perspective. We start with the conclusion that the number of primes is infinite, because that number isn't finite. Because if we assume there are only a finite number of primes, we get a contradiction. Because if we assume a finite number of primes, we can produce a brand new prime. Because if we multiply all our primes and add 1, we get another prime. Because all of our primes leave a remainder of 1 when divided into the new number. So it's prime. Because all numbers are either prime or the product of primes. And because we added 1 to the product of what we assumed were all our primes. Now, you may find this argument compelling, or you may dispute some of the logic or claims. For instance, you may want a separate proof of this particular claim. It's good to keep asking those questions, and hopefully this prime time production gave you some answers.